Hi everyone, today we're looking at Unit 4, Lesson 3, the factored form of a quadratic. So we're going to start piecing together what we've learned about factoring our trinomials and what we've learned about quadratic relations and how those two kind of pieces of information go together. So let's start by evaluating a given equation when we're given some x values. So given that y equals 2x squared plus 2x minus 4, we're going to try to figure out, well, what does y equal? So find y when x is equal to 1. So we're going to sub 1 in anywhere we see x and see what y ends up equaling. So anywhere I have an x, I'm going to replace it with a 1. Okay, so 1 squared is 1. 1 times 2 is 2. 2 times 1 is 2 minus 4. So y equals 2 plus 2 is 4. 4 minus 4 is 0. Okay, so we could actually list this as a point, right? When x is 1, y is 0. That's our y, right? I'd like you guys to pause the video and see if you can determine what's y going to equal when x is equal to negative 2. So now let's find y when x equals negative 2. Pause the video and give that a try. Okay, so you should find again when you sub in a negative 2 that y equals 0. So we've talked about this before. When y equals 0, what do those points represent? Okay, and they represent our x-intercept or the zeros of our quadratic. So we're just going to make a note here that negative, let's do it in a different color, negative 2 and positive 1 represent the zeros of the quadratic. And our x-intercepts are called zeros because, as you can see, our y value is 0 wherever our x-intercepts are. So that's why they get given that name, the zeros of the quadratic, okay? So 1 and negative 2 are the zeros. Now we're going to take a look at this. If we weren't given these x values, how might we go about actually finding out what the zeros are or finding out what the x-intercepts are? So we're going to go through the process of how does that actually work? How do I get to figure out what those are? So we're going to take this trinomial we have here and we're going to factor it and see if we can start pulling out some information once it's in factored form. So the first type of factoring we always want to try is we always want to try to common factor first. Okay, and if we look at this trinomial, hopefully we can see that we should be able to common factor out, this should have a y here, y equals, we should be able to common factor out a 2. Okay, so if I pull a 2 out of my trinomial, I'm going to have x squared plus x minus 2. All right, and then just like when we were doing our factoring unit, now that we've common factored, we have to look and say, is there another strategy I can use to factor this? And we can see that my a value here, or my coefficient on my x squared, is just 1, which means I have a simple trinomial. So we're going to use simple trinomial factoring. Okay, and to do that, we have to set up our SPF. Okay, so I need two numbers that are going to add to a positive 1, multiply to a negative 2. So we have to think about my factors of 2 are 2 and 1. Those are the only factors. So what sign do I have to put on those so that they multiply to a negative 2, but add to a negative, or add to a positive 1? If we want them to add to a positive, then my bigger factor has to be positive. So a positive 2 and a negative 1. So we're going to factor into those two binomials. We'll have x plus 2, x minus 1. Okay, so now that we're in factored form, we're trying to figure out, well, what are my zeros? What are my x-intercepts going to be? Well, as we said before, x-intercepts and our zeros occur when y equals 0. So the question is, if y equals 0, what is x? Right? So if y equals 0, what is x? So we're going to sub in a 0 for a y. And then we'll figure out, well, what is x going to equal when this happens? So once you get to this point, we start looking at the fact that we have three things being multiplied together. We have 2, we have x plus 2, and we have x minus 1. If we're multiplying any three things together and we need them to multiply to equal 0, right, because this whole equation is equal to 0, then there's something called the zero product property, which basically says in order for something to multiply together to be 0, one of those factors must be 0. So we're going to assume that one piece of our bracketed polynomial here has to equal 0. So the way we determine what x is going to be is we're going to take each of these brackets and we're going to set them equal to 0 and solve, because one of them must be equal to 0 in order for this multiplication to equal 0. So when we get that, we're going to move 2 over to the other side. We'll find that x equals negative 2. And we move 1 over to the other side, and x equals a positive 1. So therefore, we have zeros at 1 and negative 2. And if we look back where we had started, right, so if our zeros are at 1, negative 2, that's the same as my 1 that we plugged in on our first example and our negative 2. Okay, so that's how we go about finding our zeros when we're in expanded form. We have to get it into factored form to find those zeros. So let's talk about our general factored form of a quadratic. Okay, we've seen what factored form looks like when we did our factored unit, but we've never talked about what do each of those pieces represent. So the first one we have is we have this a value, okay? And the a value indicates how narrow or wide the parabola is. The smaller the number, the wider the parabola. Okay, and the a value tells us something else. So the sign on the a value tells the direction of the opening. So if a is positive, the parabola opens up. Remember, we saw when our second difference was positive, then it pointed up. Okay, that represents our a value. When our a is negative, the parabola is going to open down. So we'll keep kind of looking at the a value and coming back to these ideas, but that's just a brief introduction to it. The other two parts of our general form here, we have s and we have t. Okay, the s and the t are going to represent our zeros. So we have an s and we have t. S and t are our zeros. These are the points where the parabola touches or crosses the x-axis. They can also be called the roots or the x-intercepts. So it's lots of the same kind of word for something we're representing here. So our roots are x-intercepts. The zeros are found by determining the value for x that makes the bracket equal 0. So what's the value of x going to be that makes the bracket equal to 0? And we'll continue to play around with this. We're going to look at some factored form and see if we can determine what is our zeros, what are our x-intercepts. So I'm going to try some, and then I'm going to get you guys to try some. So the first example we have here, we have x minus 3, and we have x plus 4. Okay, now it's very easy to look at this and say, if I was just to switch the sign, that would give me my answer. But we have to be careful doing that because sometimes there's going to be more than just one number inside of our bracket. So I always encourage you to take your bracket, set it equal to 0, and then solve for x, right? So in this bracket, it's x plus 4 equals 0, so x equals negative 4. When we're determining the zeros, we're taking each bracket and we're setting them equal to 0 and then solving. So these represent our zeros. So if we wanted to graph these, we could, okay, we know we have 1 0 at 3, right, this is 3, and we have another 0 at negative 4. Those would be my zeros. My vertex would be somewhere down there. We don't need to worry about that right now, okay? But that's basically what your parabola is going to look like. I'm going to try one more together, and then we're going to get you guys to try a couple on your own. So again, we have 2x plus 5. So this is where we can't just switch the sign because we have more than one number inside this bracket that we're solving for x for. And we have 3x minus 1 equals 0. So in this case, we'd move the 5 over first, so we'd have 2x equals negative 5. And then we would divide both sides by 2 to get rid of that 2. So we'd say x is equal to a negative 5/2. So that's one of my zeros. Over here, we would move the 1 over first, and then we would divide both sides by 3. So we'd say x is equal to 1/3. So therefore, these are our zeros, right? 1/3 and -5/2. And you could, again, do a rough sketch of those to see what the problem might look like. I'd like you guys to try the next one. I know that it looks a little trickier, but keep in mind that one of our brackets, even though it's not there, is 4x. And then the next bracket is x minus 2. So set both of those factors or brackets equal to 0, and then solve for x. Pause the video to do that, and then come back and see what the answer is. So if we set both of those brackets equal to 0, we should find that our zeros are 0 and +2. Okay, so the next few examples we're going to look at, they are in expanded form. So far, we've only looked at factored form. So when we're in expanded form, we're going to need to factor to find the zeros. Okay, so in this case, we have a simple trinomial. So if we have a simple trinomial, we'll set up our SPF. So I need two numbers that are going to add to 8 and multiply to 12. Okay, those two numbers are going to be a +6 and a +2. So we'll take each of those and put them inside a set of brackets. Now that we're in factored form, we can take each bracket and set them equal to 0 to solve. So we'll have x is equal to -6 and x is equal to -2. So once again, those are our zeros. We'll try one more together, and then I'll get you guys to try that last example. So remember, if we're in expanded form, we need to get it into factored form so then we can identify what our zeros are. The next trinomial we have here, a quadratic we have 3 terms, but this time my a value is not 1, right? It's something bigger or something other than 1. So we have a complex trinomial. So we're going to need to factor using the box method or decomposition. Okay, so I'm going to use decomposition for this. I'm going to set up my SPF. Step 1 is we're going to set up SPF, right? And we'll write step 1. So I'm going to need two numbers that add to b, or add to my middle number, and that multiply to my a times c. So that's 20 times -2. So I need to multiply to a -40. So we could list our factors of 40. The ones that are going to work in this case are going to be a +8 and a -5. So step 2 for decomp is we're going to split apart that middle term using those factors we found. So we're going to have 20x squared, and then we're going to have plus those two terms, which were 8x and 5x -2. It's just showing we're just splitting apart that 3x into 8x and 5x. Okay, step 3 in decomposition is we're going to common factor the first two terms, and we're going to common factor the last two terms. So my first two terms here, 20x squared plus 8x, I can common factor out 4x. And I will be left with 5x plus 2. And from my last two terms, the only thing I can common factor out here is a -1. So if I factor out a -1, I'll be left with 5x plus 2 again. Okay, step 4. Then we need to factor out the common bracket. So my common bracket is 5x plus 2. And when I pull that out, I'm going to be left with 4x minus 1. So now that we're in factored form, okay, we're going to make sure that we set each of our brackets equal to 0. and that's going to be how we identify our zeros. So we're going to take 5x plus 2 equals 0, and 4x minus 1 equals 0. All of these steps along the way, we should have had y equals, because when we get down to this factored form, we're basically saying, okay, when y equals 0, what is x going to equal? So we have to make sure we're showing that the equation is actually equal to 0. Okay, so I take my bracketed piece, I set them equal to 0. I'm going to solve for x. So I move the 2 over by subtracting it, and then I'm going to divide both sides by 5, and we're going to have x is equal to negative 2/5. My other 0 will move the 1 over by adding it, and then we'll divide by 4. So we can say, therefore, our zeros are negative 2/5 and 1/4. Okay. So once again, when we're in expanded form, we have to choose the appropriate factoring strategy, get it into factored form, and then set each of our brackets equal to 0 and solve for x to figure out what are our zeros, what are our x-intercepts. I'd like you guys to try the next one. Take a look and decide which way you're going to factor it. I'm going to give you a hint. You're going to need to common factor first, and then you might have to try another factoring strategy after you common factor. So try to factor it, get it into factored form, and then see if you can determine your zeros by setting each bracket equal to 0 and solving for x. Pause the video and give that a try. Okay, so when we factored it, we should have been able to factor out a 2, common factor out a 2. And then from there, so first we common factored out a 2. And then after we common factored out a 2, hopefully we could see we had a simple trinomial. So we could factor that using SPF, which is what we did in that second line. You should find that you get y equals 2 times x plus 3 times x plus 3, which we can then write as 2 times x plus 3 squared. So we really only have one unique bracket that we have to solve for x. So we'll take that x plus 3 equal to 0, and then we'll solve for x. So we can say, therefore, there is only one 0 at x equals negative 3. And again, if you wanted to give it a rough sketch, okay, we know we have an x-intercept at negative 3 somewhere there. All right, and this parabola is going to point up. We can talk about why, but it is going to point up. So you can see that in this case, our vertex, or that turning point of our parabola, is the part that crosses our x-axis. Okay. Let's continue on and see if we can pull this information together to identify some other key points we've talked about in previous lessons. So some other key points we have looked at in this unit is the axis of symmetry and our vertex. So we're going to start talking about how do these key points kind of come together. We've talked about now how we find our zeros by factoring and then setting each bracket equal to 0. But how do we go about finding our axis of symmetry? We had looked at in the previous day's note that our axis of symmetry was simply the midpoint of our zeros. So the way that we're going to find our axis of symmetry is we are going to find the midpoint between the zeros. And this is the formula we show for it. Okay, it's our S and T added together and then divided by 2. Okay, so I just want to point out a couple things. This represents our axis of symmetry, but also represents, which is why it has a little v subscript, it's our x coordinate of the vertex as well. So we had talked about in another note that our axis of symmetry is simply the x coordinate of our vertex. So when we're finding our axis of symmetry, we're also finding the x value of our vertex. Once we have found the x value of our vertex, we can take that x coordinate from our vertex and we can sub it into the equation to find the y coordinate of our vertex. Because remember, every point on a graph has an x and a y value. So if we're trying to determine our vertex, we really need to find both the x and the y. So let's see if we can determine the axis of symmetry and the vertex of a quadratic relation. We're going to need our zeros first. because those are part of the formula for finding our axis of symmetry. I just want to highlight vertex. Okay, so step one, we're going to need to figure out what are our zeros. So let's just make a note here. Step one, we're going to find zeros. So we're going to need to get this expanded form into factored form. So I'm going to start by common factoring out a -3. So if we pull out a -3, we're going to have x squared minus 3x minus 4. Now, as we look at what's in our bracket, we have a simple trinomial because our x squared doesn't have a coefficient. Our a value is just 1. So if we use a simple trinomial to factor this, we'll have SPF. I need two numbers that add to a -3 and multiply to a -4. So my factors of 4 are 4 and 1 and 2 and 2. So 2 and 2 is not going to work to add to 3, but some combination of 4 and 1 will work, right? If we need them to add to a negative, then the bigger of the two needs to be negative and the other one positive. So we'll factor that into x minus 4 and x plus 1. Okay, and we're going to use those to find our zeros. So we'll have x minus 4 equals 0, and we'll have x plus 1 equals 0. So x equals 4, and x equals -1. So we can conclude, this is only our first step, but our zeros are x equals 4 and x equals -1. And in the general equation for the factored form of a quadratic, just recall that our zeros are represented by s and by t. Okay, so I'm just going to kind of divide up our space here. Okay, we have our step 1. I'm going to draw over that in black so we can see the steps we took here. So we have step 1. Okay, step 2 is that we're going to find the midpoint of our zero. So we're going to use that to find our axis of symmetry. So step 2, we're going to find the midpoint of our zeros. Which is the x value of our vertex. Okay, so the way that we do that is we take our zeros, we add them together, and we divide by 2. So we have 4 plus -1 divided by 2. So the x value of our vertex is going to equal 3 halves. Okay, so this represents the x value of our vertex. It also represents our axis of symmetry. So now we found our axis of symmetry. Let's use that to then find our vertex. So step 3, we're going to sub the x value of our vertex in to find the y value of our vertex. Okay, so we'll sub in, let's rewrite that. We're going to sub in our x value, which is equal to 3 halves, to find the y value of our vertex. Okay, so the y value of my vertex is going to equal, and I'm going to substitute into the factored form. So I'm subbing in to this equation here. I'm using the factored form of the equation. It's a little easier to work with than exponents. You can sub into either equation. So we'll have -3, and then in our brackets for x, we're going to have 3 halves minus 4, and we'll have 3 halves plus 1, the y value of our vertex. We'll have a -3, and then 3 halves minus 4 is going to be a -2.5, and 3 halves plus 1 is going to be a +2.5. So if we multiply all those together, we should get a positive 18.75. Okay, so now that we know the x value of our vertex and we have the y value of our vertex, we can conclude by saying, therefore, the vertex is, I'm going to write them both as a decimal since we did the y value. So 3/2 would be 1.5 and 18.75. Okay, so lots of key points of quadratics we're able to use there, and lots of factoring knowledge. So we have to factor, use our factored form to find our zeros, and then use the zeros to find our axis of symmetry, and our axis of symmetry to then finish finding our vertex. Okay, the last thing we're going to look at is how do we actually come up with the quadratic equation in factored form, remembering that our factored form looks like this, where s and t are our zeros. So you're going to be given information. You have to see, can I plug it in to the appropriate variable and then come up with the equation of my parabola. So it says, given that the parabola has zeros at -2 and 4. Okay, so -2 and 4. What variables do those represent? Well, those are my zeros. Okay, so my zeros are represented by s and my zeros are represented by t. So one of my zeros is -2 and the other one is 4. Okay, and it has a y-intercept of 16. Well, if I wanted to represent that y-intercept as a complete coordinate, it would be 0, 16. This is my y-intercept. Well, that's simply a point on the parabola. Just like we used to plug in points on a line, this is a point on my parabola. So this is an x and a y. So this is just a point on the graph. So I'm going to sub in all these variables that have been provided to me, and I'm going to see what variable I need to kind of still figure out. Okay, so the general form of the equation is y equals a times x minus s times x minus t. All right, so I'm going to look. Do I have a y? Yes, my y is 16. If I look at the information, I just kind of organize. Do I have an a? I don't have an a, right? I have s, t, x, and y. So for now, I'm just going to leave that as an a. And then x, I have 0 for x, minus my s. Well, my s is a -2. I can plug that in. And then x again, which we already said was 0. And then minus t, which is 4. So now I'm just going to work to simplify each side of the equation and then isolate for a. So 0 minus a -2 is going to be 0 plus 2, which is just 2. And 0 minus 4 is going to be just -4. And then I'll multiply 2 and -4, we'll get -8a. The last thing I can do here to isolate a is I'm going to divide both sides by -8. And so we'll get -2 equals a. So once you have your a value, you want to be able to write your equation. Let's just make a note. We're going to write the equation of a parabola by subbing in a, s, and t, right? We're going to sub in our a value, and we're going to sub in our zeros, which are s and t. So therefore, y equals, we found our a value to be -2, x, my s is a -2. It's going to become a +2, and then x, and my t value was 4. So that's how we go about finding our equation. We plug in all the information they give us, just like we did with a line in previous units, and then we isolate to find a. And when we write our equation, we want to sub in all of those variables and leave x and y basically. Okay, that's all for your note for today.